Imagine this. It's the early hours of October 3rd, 2025, and high above the rusty dunes of Mars, a fleet of robotic eyes snaps to attention. For the first time in human history, probes circling the red planet aren't just scanning for ancient riverbeds or dusty storms. They're locked onto a visitor from the stars, an interstellar comet hurtling through our solar system like a cosmic messenger on a one-way trip. This isn't some distant speck in a telescope. It's 3I/ATLAS, the third confirmed wanderer from beyond our sun, whipping past Mars at a blistering 30 million kilometers away. And in those fleeting moments, it didn't just pass by. It gave us a glimpse into worlds we'll never touch, reminding us that space exploration isn't just about reaching new frontiers. It's about understanding we're part of something vastly bigger. Why does this matter? Because comets like this carry frozen secrets from alien star systems, clues to how planets form, and maybe even hints at life's building blocks scattered across the galaxy. Stick with me as we dive into the discovery that has astronomers buzzing from its dramatic debut to the mind-bending data pouring in right now. If you're a space enthusiast, a curious beginner, or just someone who looks up at the night sky and wonders, this story of 3I/ATLAS will leave you staring at the stars a little longer tonight. Let's rewind to where it all began, back in the chill of a Chilean winter. On July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System, ATLAS for short, picks up a faint blur in the sky over Rio Hurtado. This isn't your garden-variety space rock tumbling lazily around the sun. No, the math checks out hyperbolic orbit, screaming speed of over 137,000 miles per hour. It's an interstellar comet ejected from some distant stellar nursery eons ago, now crashing our cosmic party uninvited. Fun fact, only two others have ever crashed this gate before. Oumuamua in 2017, that weird cigar-shaped enigma, and Borisov in 2019, our first proper comet from afar. 3I/ATLAS ? It's already stealing the show as potentially the oldest of them all, clocking in at up to 7.6 billion years young. That's older than our own solar system by a cool 3 billion. Picture it, a time capsule from a universe before our sun even lit its first fuse. Discovered by a network of telescopes designed to spot Earth-threatening asteroids, this find flips the script. Suddenly, ATLAS isn't just a guardian, it's a stargazer, pulling back the curtain on extrasolar chemistry. As it barrels in from the direction of Sagittarius, near the Milky Way's bulging heart, scientists scramble. Pre-discovery images stretch back to mid-June, thanks to Caltech's Zwicky Transient Facility. The excitement? Palpable. This comet isn't bound to us. It'll swing by, graze the inner planets, and sling right back into the void, never to return. But before it ghosts us, it's got stops to make, and Mars is first on the list. Now fast forward to the main event, our visitors on a hyperbolic joyride, clocking speeds that'll make your head spin, 61 kilometers per second, and climbing as it nears the sun's heat. Launched from interstellar depths, it's already shed its icy skin, sprouting a coma that fuzzy halo of gas and dust, thousands of kilometers wide. Think of it like a celestial dandelion, puffing out seeds as the solar wind tickles it awake. By late September, it's closing in on Mars' orbit, that thin ribbon of rock and iron we've been poking with rovers for decades. The closest approach? October 3rd at a safe 0.2 astronomical units, about 30 million kilometers, or 18 million miles. Close enough for our Martian fleet to play paparazzi, but far enough that it's no Hollywood close-up. No collisions here, folks. NASA's clear on that. Still, the proximity is gold. Mars, with its global dust storms and polar ice caps, becomes the perfect vantage point, a front-row seat to an outsider's anatomy. And as 3I/ATLAS zips past, it's not just a flyby, it's a data bonanza, feeding our hunger for what's out there. Why Mars? Because our orbiters there are tough, battle-tested machines, primed to catch what ground telescopes might miss in the glare. Cue the drama on October 3rd. At precisely 4 a.m. UTC, The skies over Mars light up, not with fireworks, but with the steady gaze of humanity's eyes in orbit. ESA's Mars Express and ExoMars Trace gas orbiter swing into action, their cameras straining against the distance. The comet appears as a dim, fuzzy white dot, drifting downward in a series of exposures, 5 seconds each for the Trace gas orbiter's Cassis instrument. It's the coma doing the talking, that glowing envelope of sublimating ices. But the nucleus, that rocky heart, estimated at 440 meters to 5.6 kilometers across, too small, too far, like trying to spot your phone screen from the moon. No tail yet in those shots. It's early days, the comet's still warming up. But the images? They're the closest we've got from any ESA craft, a testament to ingenuity. Meanwhile, NASA's Mars Reconnaissance Orbiter joins the party. Its high-rise camera snapping high-res pics from October 1st through the 7th. Perseverance and Curiosity rovers tilt their masts skyward, though from the surface it's more like squinting at a firefly. Maven dives into the atmosphere, sniffing for any whiff of interaction. Charged particles, maybe, from the comet's wake brushing Mars' thin air. Nothing explosive, no auroras flaring up like in the movies. Just pure, unfiltered science. Spectra hinting at water ice, carbon compounds, the stuff of comets everywhere. Yet in this quiet exchange, Mars isn't just a backdrop. It's a mirror reflecting how far we've come in space exploration, from Viking landers in the 70s to this interstellar stakeout. The data streams back to Earth, a digital treasure trove that has teams at ESA's ESOC in Darmstadt and NASA's JPL in Pasadena, high-fiving through screens. Diving deeper into the observations, let's break down what these machines actually caught. Start with the visuals. That GIF from ExoMars TGO, it's hypnotic, a white smudge marching across the black, the comet's core lost in its own glow. Exposure times maxed out, but the faintness wins, 10,000 times dimmer than a typical Mars snap. Mars Express chimes in with shorter bursts, half a second per frame, stacking images to chase spectra via Omega and SPICAM. Early peaks? Promising but noisy. No full composition yet, but whispers of cyanogen and diatomic carbon, hallmarks of cometary outgassing. NASA's side? HiRISE delivers crisp frames, revealing the coma's teardrop shape from earlier Hubble shots evolving, dust grains spiraling out like a slow-motion explosion. Fun analogy, imagine blowing on a snow globe from across the room. That's the solar wind sculpting this thing. Quantitatively, the coma spans a few thousand kilometers, nucleus temperature, hovering around -100 Celsius, spiking as it nears perihelion. Radiation detectors on Curiosity tick up slightly, cosmic rays from the comet's passage, but no methane spikes or seismic hums. Just baseline weirdness, the kind that fuels peer-reviewed papers in Nature. And the rovers? Perseverance's Mastcam Z captures horizon blurs, while InSight's dust-covered seismometer stays mum. It's collaborative magic, ESA, NASA. Even amateur scopes in Chile and South Africa syncing data. This isn't solo exploration, it's a global relay, proving space isn't a solo sport. What does all this tell us about 3I/ATLAS itself? Peel back the coma, and you find an active beast, icy nucleus belching gas as sunlight licks it awake. Early JWST spectra from August, they scream organics, water vapor, CO2, maybe amino acid precursors. It's a chemical snapshot from another star, ejected perhaps by a rogue planet's gravity eons back. Age estimate, that 7.6 billion years isn't hype. Isotopic ratios suggest formation in a protoplanetary disk before our galaxy's arms fully spun up. Compare Earth to this. Our blue marble's a whippersnapper at 4.5 billion, while this comet's seen stars born and die. Data breakdown, speed at Mars flyby, 50 kilometers per second inbound. Dust production rate, low for now, but ramping to 10 to the 4th kilograms per second by perihelion. No fragmentation yet, unlike Oumuamua's spin-up mysteries. Instead, steady outgassing, painting it as a normal comet, yet utterly alien. Theoretical aside, if life's ingredients hitchhike on these wanderers, could 3I/ATLAS seed ideas for panspermia? Evidence. Slim, but those organics echo Borisov's methanol lines, per Science Journal models. It's not speculation, it's the edge of knowledge where facts flirt with what if. Stack it against its interstellar siblings, and 3I/ATLAS shines unique. Oumuamua, that 2017 cigar, 400 meters long, tumbled silently. No coma, no tail, sparking SETI scans for artificial signals that turned up zilch. Borisov 2019's gassy cousin spewed familiar stuff, HCN, the cyanide precursor, but dimmer, smaller. Now 3I/ATLAS, bigger nucleus, brighter coma, older vibes. Table it out mentally. Oumuamua, asteroid-like, 100 meters by 1 kilometer, speed 26 kilometers per second at perihelion. Borisov, Comet Classic, 1 kilometer nucleus, 30 kilometers per second. 3I/ATLAS, 440 meters to 5.6 kilometers core, 61 kilometers per second inbound, hyperbolic eccentricity 6.5. Diversity screams. Interstellar space tosses out oddballs, from rocky drifters to icy sprayers. Why? Ejection dynamics. Gravitational slingshots from binary stars, perhaps. Fun fact, if scaled, Oumuamua's shape was like a massive potato. 3I/ATLAS feels more potato salad, frothy and reactive. This trio hints our solar system's not special. Comets everywhere, faring chemistry galaxy-wide. As ESA's Colin Wilson puts it, these flybys rewrite extrasolar textbooks, 1 pixel at a time. Peering ahead, the comet's not done dazzling. Post-Mars, it's inbound to perihelion on October 30th, skimming 1.4 astronomical units. Just inside Mars's path, 210 million kilometers from the sun. Heat cranks up. Expect tail growth to millions of kilometers, visible to backyard scopes by December. JWST at L2 locks in infrared pulses, hunting thermal maps. ESA's JUICE mission? It'll spy it in November, en route to Jupiter's moons. Perfect for composition cross-checks. NASA's fleet piles on. Parker's solar probe dodges close for dust samples. Europa Clipper times a peak. Long-term, data feeds models on interstellar medium. That sparse soup between stars laced with hydrogen clouds. Implications? Huge for future hunts. ESA's Comet Interceptor launches 2029, primed to chase these ghosts. And theoretically, if we spot more, it bolsters the Oort cloud's interstellar mix. Our own halo peppered with aliens. SpaceX's Starship dreams. Imagine redirecting one to snag a sample. For now, it's eyes on the sky, turning what if into we did. As 3I/ATLAS fades into the inner solar system, let's zoom out. This flyby isn't just pixels and plots. It's a milestone in space exploration. We've turned Mars, a world once thought dead, into a bustling observatory, rovers and orbiters tag-teaming data like a well-oiled crew. Key takeaways. Interstellar objects are common enough for third strikes, diverse enough to challenge models, and precious enough to rally global efforts. From Atlas's alert to JWST's gaze, it's proof we're not passive watchers. We're active seekers, piecing the cosmos one comet at a time. But here's the thought provoker. What if these wanderers aren't accidents? What if they're the universe's way of sharing recipes? How stars cook up worlds, how life might spark, or darker, could hidden tech lurk in their ices, echoing Oumuamua debates? Labeled theory, sure, backed by null SETI results so far. Either way, 3I/ATLAS whispers we're connected. Threads of ice linking Sol to Sagittarius. So space fans, what's your take? Is 3I/ATLAS a boring rock or a bearer of cosmic secrets? Drop your theories in the comments. Let's geek out together. If this dive into interstellar comets and Mars mission updates hooked you, smash that like button, subscribe for more space exploration breakdowns, and hit notifications so you never miss a launch. Check out my vid on Oumuamua Mysteries next. Link in the description. Thanks for joining the journey. Remember, the stars aren't silent. They're just waiting for us to listen closer. Clear skies,